All right, so reviewing, we have our standard form here, ax squared plus bx plus c. If we wanted to find the axis of symmetry, we use the equation x equals opposite of b over 2a. Negative b over 2a. Move that chair. Pull the chair out. Okay, vertex form, y equals a times x minus h squared plus k. Remember, in vertex form, we can identify the vertex as h comma k. So these two numbers. So let's look at this graph over here and let's identify these key features. So the vertex is the turnaround point. So right here, at this point, it's going uphill. I know we have usually have little arrows here. So right 4, up 2, so the vertex is 4, 2. Is that the highest point or the lowest point? Highest, so we also call that a maximum. 4, 2. So you may want to let's lightly label stuff on our graph. So vertex / max. Roots, x-intercepts. So that's where does it hit the x-axis?
So at 2 and 6.
At 2 and 6. Okay, so for these, I am okay if you write this as, so let's label these zeros. I'm okay if you say that this is x equals 2 and x equals 6. Or if you wrote these as 2, 0 and 6, 0. Or a squiggly bracket 2 and 6. How about x-intercept, or y-intercept?
-6.
-6. So that's the ordered pair 0, -6. That one should be an ordered pair.
Wait, is our homework just going to be like this?
This is your first example, so just hang tight. All right. Axis of symmetry, we're trying to see where does the mirror image happen. It happens at the vertex, but a vertical line. So this is the axis.
So at 4.
At 4, yep. And it says line of symmetry here, that's the same thing. So x equals 4. And notice it is the x value of your intercepts. Or of your vertex and max. It's the x value. Okay. The next thing we're going to talk about is increasing and decreasing. This is going to be interval notation. Whenever we think and we read this graph, we read it left to right. So I'm thinking if I were to put a little guy here, I were to put a person on the graph right there, and they start walking on that graph, are they going uphill or downhill? Uphill. So they're increasing until they hit the top, right? So all the way from negative infinity, because this keeps going down, so I could have plopped that guy on the graph anywhere. So all the way from negative infinity until he hits the top. Well, what is that? That's a 4. So going left to right, I stop at 4, and he stops increasing at 4. He hits the top. It's negative infinity because the line has an arrow. Yes. And I use a parenthesis because we can't include negative infinity. So we have to think back to unit 3. It's a while ago. And then 4 is included. So what symbol did we use?
We used to.
Yep, we used that one. The closed bracket or the brace.
staple.
The staple, yeah, it looks like a staple. Right, Andrew? Okay, now when he hits the top and he keeps going this way, what's happening to him now?
Decrease.
He's decreasing, he's going downhill. So starting at 4, he starts going downhill. Well, if these don't have an arrow on them, we're going to add arrows. He's going to keep going downhill forever till someone plucks him off that line. So to negative infinity. Okay. Well, actually, we're still talking about our x's, so really going to the right. So forever to the right, he's going to keep going down. So it is going to be to positive infinity because we're thinking about left and right. Even though he's going down, he's still going to the right.
Show if they're going to the left, it's negative.
So let's look at domain and range. We have to remember that domain is talking about all of our x values. So let's write that, x values. So what x values are we looking at? We're looking left to right. When I come in from the left side on my graph, I see this arrow. That means it's going to keep getting wider to the left forever. So it's eventually going to hit every value to the left of 0. So negative infinity is where our domain starts. And if it goes to the right forever, it goes to positive infinity. Every parabola that's going upwards or downwards, which you will see this year, we're not going to see any parabolas on their sides this year. Every parabola going upwards or downwards is going to keep getting wider forever and ever, so the domain will always be negative infinity to infinity. Range is your y values. So we are thinking lowest to highest. Okay, so what's the lowest point on this graph? Well, if I come up from the bottom, I think I just heard it. Negative infinity. Good, because these arrows tell me, oh, well, keep pushing your hands. It's going to keep going down forever. So my domain actually would start at negative infinity. That's the lowest point.
And then go up to 4.
And then go up to this point, but we're thinking y values. So what's the y value of this coordinate? 2.
Oh,
So
yeah.
how high does it go? Too high. 2 points high. Does that make sense? We're going to keep practicing it, so the first time you did it, it's okay if it's not like ultra clear right now. What questions do you have for me off this first example? Okay, so what you're going to be tasked to do with is now, instead of me giving you the graph, we're going to use our skills that we have from last class to take this equation. It's in vertex form. Find these informations. We've found vertex, max, zeros, y-intercepts, and line of symmetry. We've been finding that for the last 2 classes. That's not the new part. The new part is, well, we're going to graph it and we're going to analyze it. So we're going to see, is it increasing, decreasing, which parts are increasing, decreasing, and analyzing domain and range. But we're throwing it all together today, so it is also some review. So let's take a look at this vertex form equation. So as I look at this, let's first think, is this going to be a U shape or an arch shape?
U shape.
U, because in front of the parentheses is positive. So I know it's going to be this way, which tells me max or min? Min. Good. I'll have a min. So what is my vertex?
2, -3.
2, -3. Very good. So the 2 is here. Even though that has a minus sign, the minus is part of the formula. And then this -3. I know that is also my minimum. Also, line of symmetry is x equals 2, the x value. All right, great. We just knocked out half of it right there. Maybe, close to half of it. All right. If we wanted to start graphing this, we could. So the first ordered pair is 2, -3. So we start at our origin, right 2, down 3. Right there. Okay, zeros. Well, it's what we did on that board right there, right behind me. Okay, we took the equation and we solved it. So if we take this equation, I didn't really leave you a ton of room. I'm gonna say my bad on that one. So we're gonna squeeze it in there, or you could get a piece of scrap and then like tape it to it or staple it to it. That might be best. Maybe get a piece of paper, loose leaf out and tape it to it, or staple it to it. Or I'm going to fit it in this little section here. Okay. If you know you write big, write somewhere else. Or you could go underneath, because we can do this one underneath. All right, so I'm going to take this equation and I'm going to solve it, which means I'm going to replace the y with what?
0.
0. Very good. So 0 equals x minus 2 squared minus 3. I'm going to zoom in just on that portion now. So I want to get x alone, so first I'm going to kick this 3 out. How do I get the 3 to the other side? Add it. Bless you. So this becomes 3 parentheses, or equals, parentheses, x minus 2 squared. Now, how do I get to this x if it has a squared outside?
You got square root.
This is where I square root. So if there was a number in front of the parentheses, like a, I don't know, like a 6, what would I do?
No, you would just divide.
I would have to divide by that number before I square root. Okay, that appears on your homework. Miss Long. Oh, thanks. Oh, yes, I will. I will get those after my notes today. I can do today. Okay. Yeah, maybe wait till Friday. Okay, sorry. Okay. Bye. Okay. So square root both sides. So when I square root this side, I get x minus 2. When I square root the 3,
You get 1.5.
good. So square root 3 is, actually,
It's not.
3 divided by 2 is 1.5, but we're square rooting.
Oh.
So square root of 3 is 1.7.
I was close enough. But,
Close, but not close enough.
Yeah.
Okay, so is it just 1.7?
Negative 1.
Yeah.
Positive or negative? So good. So both versions. Could be positive 1.7, could be negative. So now I'm going to create 2 equations. So one of them is x minus 2 equals 1.7. The other is, I'm going to squeeze it in here, x minus 2 equals negative 1.7. So 2 equations, 1, 2. Because I have 2 x-intercepts. Add 2 to both sides. X equals 3.7. Add 2 to both sides. X equals?
Negative.
Let's plug it in our calculator. 0.3, a positive 0.3. So what's that? 0.3 and 0.3 are the same. What's that look like on our graph? Okay, so 0.3, that's not quite halfway, but it's on our x, so 0.3 maybe about here. Not 0, but not quite half. Just do your best. It's a small graph, right? And 3.7, that's right 3, 1, 2, 3, almost 4. So there. And connect your dots. Put arrows on the end of your parabolas. Now, what did we just find? Zeros. Good. So my zeros, I'm going to write x equals 3.7 and x equals 0.3.
Or can I do the squiggly?
Or you can do the squigglies for sure. So squiggly bracket, 0.3, comma, 3.7. Close your squigglies. Or 0.3, comma, 0. So ordered pairs is fine, just like we did on number 1. Y-intercept. Oh, it's not very clear where it passes the y-axis, is it? You guys, can you notice for sure the ordered pair where it hits this y-axis? No. So what could we do? We could plug in 0 for x and solve. So I'm going to do that right down here. And I'm saying in my equation, in my formula here, I'm going to plug in 0 in for x. So this is 0 minus 2 squared minus 3. 0 minus 2 is negative 2 squared minus 3. Negative 2 squared is 4 minus 3, 1. So that ordered pair is 0, 1. You can do that every time for the y-intercept. And we did that on day 1 notes. It's just been a couple days. So we found all that information. Now we need to find increasing, decreasing. So when I put my little guy on the graph here, when I put him on, is he going to be climbing or sliding? Sliding, so he's decreasing. So first this time we're decreasing. So I even like to go and do the decreasing first. So from all the way to the left, so negative infinity, when does he stop sliding downhill? Well, right there. What's the x value?
Negative.
No. What's the x value? 2. Good. And then at 2, he starts climbing. So increasing from 2 to forever. Infinity. So increasing, decreasing is always focusing on domain. Always focusing on the x's. What's happening left to right. Now for the domain of the entire graph. How far left does it go? How far right does it go? Keeps getting wider and wider forever. So negative infinity all the way to positive infinity.
Which
Okay, range, y values. What's the lowest point? Right here, negative 3. What's the highest point? Infinity. Questions on the second one? We got one more like that. This one is in standard form. So when we want to find our vertex and axis of symmetry, we usually start with axis of symmetry first, because we use the formula x equals negative b over 2a. So what is our b? 6, so opposite of 6 is negative 6 over 2 times a. What's our a? 1. So 2 times 1. So negative 6 divided by 2 times 1 is 2. So negative 3. So our axis of symmetry, or line of symmetry, is x equals negative 3. Okay, so now to find the vertex, we would plug in negative 3 in for x, both of those x's, and solve. Okay, however, here's what I can also do. I can grab my calculator. I can press y equals. Got something in there, clear it out. So it's x squared. So your x is next to your green button, x, and then your squared is diagonal from the 7. Plus 6x minus 7. And if I want to look at my graph, I can press graph to give myself a little visual. Ooh, it's going to go swoop way down.
Yeah, you can't even see it.
Can't even see it. So I'm going to have to make my graph a little different. Now if I want to look at my table, I'm going to go second graph. I need to have -3 in my visual. So if you don't see -3, you might need to scroll up. -3, comma, -16 is my vertex. -3, comma, -16.
So this is gonna have a
Minimum. It's a U shape. So that's our lowest point. -3, -16 is the lowest point. Y-intercept, let's see if we can find it here. It's going to be 0, comma something. 0, comma, we'll look at x0. 0, -7. Right there. 0, -7. Now, zeros, let's see if our graph gives us, our table gives us those. So this is where we're looking for 0 in the y column. There's one. So one of our x-intercepts is at 1, 0. So x equals 1. If I want to find the other one, which direction should I go?
Up.
Up. -7, 0.
Yep. Which you can still just squiggly bracket.
Which I can still use the squiggly brackets. Okay, write yourself this note. Another way to find that without the graphing calculator is you could have factored and solved or used the quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Remember that? That old thing? Okay, so you could have done that. Alrighty. Now, I've got all the important information. I need to fit -3, -16 on my graph. So I'm going to save you a second counting. If I go by 2's, so this would be -2, -4, -6, -8, -10, -12, -14. I still have to create another line on my graph. So -16, and then kind of connect these. So -3, just because I went up by 2's on my y, do I have to go up by 2's on my x? No, they can have different scales. So my x is still going to be increasing by 1's. So I need to go left 3, down 16, there. That's my vertex. My x-intercepts are -7, so left 7 is here, and a +1 here. And let's connect them. Don't make it a V shape, make it a U shape. What questions do you have about how I just graphed that? Okay, so let's find increasing or decreasing. Again, if I put this little guy right here, is he going to be sliding or climbing?
Sliding.
So he's decreasing to start with. So from -infinity, when does he stop decreasing?
-16.
Right here, but remember we're going left to right. So he stops decreasing here, but what is that? X. -3.
Yeah.
Brace. Then he starts increasing again, going uphill, starting at -3. Does he ever stop increasing? Nope.
Goes all the way to infinity.
He keeps climbing forever. Poor guy's gonna be wore out.
Can't even stop it. It'll just slide back down.
Nope, yep. All right, domain. It's the same thing. This thing's gonna keep getting wider forever.
Yes.
So domain is -infinity to +infinity. Range. bottom to top.
So negative 16.
Negative.
Positive.
Negative 16 to positive infinity. Questions? Okay. Flip it over when you're ready. This backside's quicker. Quicker picker upper. All right, so we're just analyzing two quadratics now. So it says function 1 is, and I give you this table, function 2 is here. And we want to analyze them. We're talking about minimums over here and maximums. That's what this is focusing on. Select all that apply. This is EOC type questions. This questions like this will appear on your test. So if I want to compare maximums and minimums, I may want to graph these and look at the graphs. So I'm just going to sketch. So let's start with function 1. The order pair 1, 5. So I'm going to just create, going about 5 in each direction. And this is just a sketch. It does not have to be perfect. I just need to visualize these. So 1, 5 is right 1, up 5. 2, 2, right 2, up 2. 3, 1. 4, 2. 5, 5. So does this have a max or a min? Min, so this is number 1. I'm just going to put number 1 next to it. So it has a minimum right there. Now, the graph x squared minus 1, to save myself some work,
Just type it in.
I'm just going to put it in my calculator. So y equals, clear, x squared minus 1. Second table. I'm going to look at the table. Oof. There's a lot going on. I'm going to look at my graph really quick so I can see what's happening. So I need to go much closer to 0 to see what's going on. But even just by looking at this graph, I can tell it has a what? Minimum. Is that minimum higher or lower than the other one? It's lower. Okay. So let's look at our graph now, our table. I'm going to go closer to 0, and I'm just going to plot a couple of these points. I'll use a different color so we can tell them apart easily. So I've got 0, negative 1, and I just found the turnaround point on my graph, so I found the vertex is right there, 0, negative 1, and I'm just going to graph a couple points on each side. So it goes here and here. I'll just plot those other 2 more. That's number 2. So yes, they both have a minimum. That is true. Do any of those say both functions have a minimum? The third one. Okay, so let's start reading top down now.
That says they have the same minimum.
Ooh, good catch. That says same. So get rid of that. All right, so let's start top down. I'll take my time now. It says function 1 has a larger minimum than function 2.
Yes.
Yeah, that's true. It's larger, it's higher. So that's true. Maybe we even circle it. Okay, function 2 has a larger min. No, we just said function 1 did. Okay, this one's wrong. They have the same. That's not true. Number 4, neither function has a max. They both have minimums.
Yep.
Yeah, that's true. 5, neither function has a minimum. That's not true. Last one, function 1 has a minimum. Function 2 has a max. Not true. Questions? Second one, which function has a greater minimum, aka which one is higher? So here is function f, and on your graph you have function g. So function g is right there. I'm going to look in my graph. I'm going to graph function f in my calculator. Tori? I'm going to graph it in my calculator, so press y equals. Almost done here. Clear this out. Oh, I got a little dark. 4x squared plus 4x minus 3. And your iPad calculator does do this as well.
Oh, nice.
Now, if I look at the graph,
There's nothing.
it says which function has a greater minimum.
Function G.
Which one? The one on my calculator or the one on the paper?
Paper.
The one on the paper has a higher minimum.
G has a greater minimum.
So here, this, I'm even going to write higher than F. So it has a greater minimum. So which one says G has a greater? The second one. Okay. And the last one. See, how many roots do the functions have in common? That's what we're analyzing now. Roots means x-intercepts. So I'm going to, my G is on the graph. My F I'm going to put in my calculator. So clear that out. X squared minus 4x minus 5. I'm going to press graph just so I can see what's going on. All right, oof, that swoops way down. But I can kind of see where it crosses. I'm noticing that it turns around about here, which looks like about 3 negative something. So now when I look at my table, I'm going to go second graph. I know at 3 something, it turns around. So 3 negative 8, it turned around.
Well, it says 2 negative 9.
Oh, yep, 2 negative 9. So I was close to it, right? I was close. So this negative 9 is here is where it turns around. And I know that because on either side there's a negative 8, so it's mirroring. So right 3 down to negative 9 would go way off my graph. We're analyzing, so it would be like way down here, even further than that. Way over here, actually, though. So I'm supposed to be analyzing my zeros. So this says it hits the x-axis at negative 1, 0, right there, and 5, 0, right there. So my parabola goes something like this. Which root do they have in common? This one. Do they have the other one in common? No. Do they share both roots?
Well,
No. One is negative 1, 5, and the other is 2, 5. So let's see here. Number 1 says F and G share the same roots. No, that would be both of them. No. The second one says F and G share one root in common, but each have another root that is not shared. That is true. And F and G have no roots in common. That's not true because they share the 5.